You're looking at something that cost 6 billion euros, a structure as tall as a 6-story building. When it isn't here, you can't see it. No towers, no cables, nothing at all. On one side, the Adriatic at 52 inches of tide. On the other, Venice at 28 inches dry. For the first time in 1,200 years of history, a flood of that magnitude didn't wet a single inch of St. Mark's Square. 11 months earlier, that same square was underwater. November 2019, the second worst flood in the city's recorded history. What happened between those two moments is one of the most extraordinary engineering stories ever told. The name is MOSE, a submerged, invisible, silent shield, built over 17 years on the bottom of the sea. If you hit like right now, you help this story reach more people. It means a lot to us. Today, we're opening that black box, understanding how the physics of water, air, and steel saved an entire city from the abyss. To understand the shield, you first need to understand what it's holding back. Venice is not built on solid ground. It never was. Venice was built on 10 million wooden logs driven into the mud, a feat of 5th century engineering that defied all logic. Without oxygen or light, that wood doesn't rot. It petrifies. Some of those logs are over 1,000 years old and still support palaces. For centuries, isolation was the protection. The lagoon acted as a natural moat. No army could cross it easily. Twice a day, the tide entered the lagoon, flushed the canals, and returned to sea. It was a perfect cycle. For centuries, it worked. In the 20th century, everything changed. Industry around the lagoon began extracting groundwater on an industrial scale. The ground gave way. Venice sank 9 inches in less than 50 years. For a city at sea level, every inch counts. At the same time, the Adriatic sea level began to rise. Two opposing movements converging on the same point. Acqua alta had always existed. What was once a rarity became routine. What reached the ankle started reaching the knee. Saltwater doesn't just soak, it corrodes. The mosaics of St. Mark's Basilica, over 900 years old, began to dissolve. November 2019 was the breaking point. A tide of 74 inches, the second highest ever recorded. The city collapsed. The MOSE system was 90% complete. The engineers knew it could work. Nobody dared press the button. Bureaucracy, fear of technical failure, political pressure. The city flooded while the shield slept on the ocean floor. To build any barrier here, engineers had to defeat 3 enemies at the same time. The first enemy is hydrostatic pressure. At 50 feet of depth, every square foot of structure bears the weight of a car. A rigid, fixed barrier would be destroyed within months. The Adriatic has waves, storms, swells. The mechanical force of the sea is relentless. The second enemy is invisible. When different metals touch inside salt water, they form a natural electric cell. Salt water conducts electricity. The steel literally dissolves. A poorly designed structure would turn to dust in under 2 years. The third enemy has a life of its own. Mussels, barnacles, and algae grow on any submerged surface that stays still. Within months, they cover everything. If a hinge seizes on the ocean floor with 330 tons of steel above it, there is no crane in the world that fixes that problem. The solution for 3 enemies at once had to be something no engineering had ever attempted before. The engineers designed a box, a hollow steel box, 66 feet wide, up to 16 feet thick, and 92 feet long. Under normal conditions, that box sits full of seawater and rests in a concrete cradle on the lagoon floor. Invisible, silent. When the forecast tide exceeds 43 inches, the system goes on alert. This is where physics takes over. Compressed air is injected into the gates at a pressure of 36 pounds per square inch. The air pushes the water out. The interior of the box empties. As air replaces water inside the box, the weight drops. Buoyancy overcomes gravity. The gate begins to rotate. That is Archimedes' Principle, discovered 2,200 years ago in a bathtub in Greece, lifting 330 tons of steel in the Adriatic Sea. Each gate weighs up to 330 tons when empty. The 78 gates together contain more steel than the entire Eiffel Tower. Here is the detail that sets this project apart from everything before it. The gates are not rigid. They were designed to oscillate. The air inside the box acts as a giant shock absorber. When a wave hits, the air compresses, absorbs the energy, and releases it back. The hinges are the heart of the system, made from Super-Duplex, a steel and chromium alloy engineered to resist corrosion in salt water. To defeat galvanic corrosion, zinc blocks were installed along the entire structure. These are the sacrifice anodes. Those blocks corrode deliberately in place of the steel. They are organs that die so the main body can survive. If you're fascinated by Venice's architecture, the Lego Architecture Venice set is the piece missing from your office shelf. Link in the description. Underneath all of this, there's something straight out of a film. Concrete tunnels where engineers walk beneath the ocean floor. October 3rd, 2020, 8:35 in the morning. The compressors at all 3 lagoon inlets switched on simultaneously. Sirocco winds were pushing a mass of water from the Adriatic toward the lagoon. Forecast, a tide of 53 inches. In under 75 minutes, all 78 gates were in the blocking position. Synchronized, precise, 0 failures. Something happened that no camera had ever filmed before. A yellow line appeared in the middle of the sea. Outside, 52 inches. Inside, 28 inches. A water step of 24 inches, visible to the naked eye. The Adriatic kept attacking. The gates oscillated with each wave, absorbing the impact, releasing the energy, not yielding an inch. At St. Mark's Square, nothing. Dry ground, pigeons walking. For the first time in 1,200 years, the tide knocked on the door, and the door held. For the engineers who spent 17 years building that system, that day was the direct redemption of the failure of 2019. What no one sees is underneath. While the gates held back the Adriatic, the concrete tunnels below remained fully operational. Engineers monitored the internal pressure of each of the 78 gates individually, making real-time adjustments as each wave arrived. The gurgling of water expelled from 78 gates simultaneously created a low-frequency vibration felt on the ground of nearby islands. The October victory came with a reminder: biology never stops. After the first tests, divers found the hinges covered in barnacles. Sediment from the lagoon floor also builds up in the cradles. If the slot isn't clean, the gate won't seat properly. The answer is robots. ROVs and technical divers carry out underwater maintenance without needing to drain the channels. Every time the system is activated, the operational cost runs to approximately 300,000 euros. Energy, crew, mechanical wear, a steep price. The cost of not activating is steeper. A single severe Aqua Alta episode causes hundreds of millions in damage to the city. There is, however, a problem no one wants to face. With sea levels rising globally, MOSE will need to be activated with increasing frequency. The dilemma is real: save the architecture or save the ecosystem. For now, engineering has bought time. How much time? No one knows. Venice is 1,600 years old. It survived empires, plagues, and wars. Now it faces an enemy with no army and no flag. MOSE rests on the ocean floor most of the time. Nobody sees it. Nobody hears it. The city above has no idea it's there. The city built on logs, driven into the mud, now depends on steel, compressed air, and physics to stay standing. That's 1,600 years of accumulated engineering, from wooden piles to steel gates, from medieval intuition to Archimedes' law. Every mosaic in St. Mark's Basilica that still exists today is, in part, the result of an engineering decision made decades ago. The question that remains is not whether MOSE works. October 2020 answered that. The question is how long it will be enough. Under current projections for 2050, the system may need to stay activated for weeks at a time. The lagoon begins to suffocate. The dilemma is real. 6 billion euros, 17 years of construction, 78 gates sleeping on the ocean floor, all to protect a city that insists on existing. Perhaps that is the greatest lesson of MOSE. The most powerful engineering is the kind you never need to see to trust. If this video made you see engineering differently, leave a like. It goes a long way in helping this channel keep telling stories like this one.